So if both the inputs are low, 0 and 0, so what is the basic difference between analog electronics is constructed using only the two logic levels. It may be a varying electrical signal or data is represented through one. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Trying to understand the fag end of this chapter, what we studied as semiconductor physics. We will here understand a branch called digital electronics, a newly invented branch of physics, something called as digital electronics, where we actually try and understand something called as logic gates. Interesting topic, always a one marker based on this, something called as logic gates. So in this session, we make an effort to understand something called as digital electronics. Hitherto, before we creep in and understand what is digital electronics, in our earlier chapter, we are familiar with concepts on electric current, alternating current, and so on. Now let us try to understand how digital electronics, the word digital within quotes, is different from the aspects of electric current or alternating current. ಈ ಒಂದು ಸೆಷನ್ ಅಲ್ಲಿ ನಾವು ಅತಿ ಮುಖ್ಯವಾಗಿ ಹಾಗೆ ಡಿಜಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅನ್ನೋ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಅಥವಾ ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ಗೆ ಡಿಫರೆಂಟ್ ಆಗಿದೆ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಫೈನ್. Now the branch of electronics is basically classified into two groups. Very important to know this. Fundamentally, the branch of electronics is classified into two groups. One, what we call as analog electronics, and the other one what I call as digital electronics. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅನ್ನೋ ಬ್ರಾಂಚ್ ಅನ್ನ ಬೇಸಿಕಲಿ ಎರಡು ಡಿಫರೆಂಟ್ ಬ್ರಾಂಚ್ಗಳ ಕ್ಲಾಸಿಫೈ ಮಾಡಿದ್ದೀವಿ. ಮೊದಲನೇದನ್ನ ಅನಲಾಗ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ಎರಡನೇದನ್ನ ಡಿಜಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. Exactly as you have your analog watches and digital watches. So what is the basic difference between analog electronics and digital electronics? Dear students, in analog electronics, data, or what we call as information, in analog electronics, data, which is the information, is represented by continuously varying signals. Continuously varying signals andre adana electrical pulses ant karitivi. So in analog electronics, data or information is always represented in terms of continuously varying signal. It may be varying electrical signal or varying voltage signal. See, for example, it may be a varying electrical alternating signal, alternating wave ಅಂತ ಓದಿದ್ವಲ್ಲ. So data may be represented in the form of electrical signals, or data may be represented in forms of voltage signals. ಇದನ್ನ voltage pulse ಅಂತ ಕರಿತೀವಿ. So what to understand here prominently is, in analog electronics, any data or any information is represented in form of continuously varying signals. It may be a varying electrical signal or varying voltage signal. Then what is digital electronics? In digital electronics, always data is represented by binary numbers 0 and 1. High school alli odirtira binary numbers anta. So 0 and 1 are called binary numbers, and basically data is represented using binary numbers. How little next we understand. And using electronic signals called digital signals. So beautifully, to understand the introduction, fundamentally electronics is classified into two types. One, what we call as analog electronics. The other one, what we call as digital electronics. In analog electronics, data is represented, information is given in the form of continuous varying signals, either electric pulses or voltage signals. Whereas in digital electronics, we represent any data using two binary numbers, that is 0 and 1. Now, with this understanding of digital electronics, we try to define something called as logic gates. Logics ಅಂತ ಕೇಳಿರ್ತಿದ್ರಲ್ವಾ ಯಾವಾಗಲೂ? Something which is very informating, logical sense ಅಂತ ಕರಿತೀವಿ. Then what is a logic gate here? What do I mean by logics? Simple to understand. A logic is based on the simple idea. Any logic is based on the simple idea that there are only two possible states. ಹೇಳಿದ್ನಲ್ವಾ, 0 and 1. So, only two possible states, binary states in digital electronics, 0 and 1. And there cannot be any in-between levels like analog electronics. In analog electronics, you can have metastable states. Metastable andre something in between anta artha. But digital electronics will never allow that. Either data is represented through 0 or data is represented through 1. No metastable state. Please to understand, here 0 is called the low state and 1 is called the high state. Or 0 is called the off state and 1 is called the on state. Very important representation in digital electronics. 0 andre low state ant karitivi, 1 andre high state ಅಂತ ಕರಿತೀವಿ. ಅಥವಾ 0 ಅಂದ್ರೆ ಆಫ್ ಸ್ಟೇಟ್ ಅಂತ ಕರಿತೀವಿ, 1 ಅಂದ್ರೆ ಆನ್ ಸ್ಟೇಟ್ ಅಂತ ಕರಿತೀವಿ. Generally, electric current ಅಲ್ಲಿ switch is on, switch is off, circuit is on, circuit is off ಅಂತ ಹೇಳ್ತಿದ್ವಲ್ಲ. ಅದೇ ಡಿಜಿಟಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅಲ್ಲಿ if anything is in the off state, it is called to be low state or 0 state. Anything which is in the on state is said to be high or it is said to be in the one state. You cannot have an in-between state between 0 and 1. Everything based around the concept of two logics, as I told, logic 1 and logic 0 or the high and the low logic levels. So this concept, the formation of a zero state or a high state. The formation of an off state or an on state, zero state or a one state, leads to the formation of electrical circuits, what we call as logic gates. So, if at all a question is posed to understand what is a logic gate, the answer is, it is an electrical circuit which is constructed using either the low state or the high state, zero state or the one state. And therefore we say there are three fundamental or basic logic states. ಮೂರು ಫಂಡಮೆಂಟಲ್ ಅಥವಾ ಬೇಸಿಕ್ ಲಾಜಿಕ್ ಗೇಟ್ಸ್. ವಿಚ್ ಆರ್ ದೇ? ಆರ್ ಗೇಟ್, AND gate and NOT gate. So to summarize this issue, logic andrenu, it shows that in digital electronics you have only two possible states and no in-between states. Which are those two possible states? The zero state, which is the low state, or the off state, or the one state which is high or on. There cannot be any metastable states in between states. And what is a logic gate? It is an electrical circuit which is comprised of the logic levels. An electrical circuit built using the zero state or the one state, the high state or the low state, is called a logic gate. And how many fundamental logic gates? Three. Which are they? OR gate, AND gate and NOT gate. Now, we shall discuss the OR gate, AND gate and NOT gate in detail now. Yavaglu exam alli very important. They ask you to write the expression called Boolean expression, symbol or logic table, truth table for a given gate. So this is the OR gate. The first fundamental gate I am studying is the OR gate. Very beautiful term. OR yake, I will come next. So this is the symbol or representation of an OR gate. I told any logic gate is constructed using only the two logic levels 0 and 1. So this is the OR gate. If you observe the representation, the symbol, there are two inputs here, A and B are called the inputs to the gate, and Y is called the output of the gate. So OR gate ಅಲ್ಲಿ ಎಷ್ಟು ಇನ್ಪುಟ್ ಗಳಿರುತ್ತೆ? An OR gate has two inputs and a single output. And this output is what is called the Boolean expression. So what is the Boolean expression for OR gate? Y equals A plus B. Observe this very, very carefully. It is nonsense saying Y equals A plus B. That plus simply shows the mathematical operation it performs. You have to read it as Y equals A or B. Y equals A plus B ಅಂತ ಹೇಳಬಾರ್ದು. ಪ್ಲಸ್ ಅನ್ನೋದು ಈ OR gate ಮಾಡುವ mathematical operation. You are reading it as Y equals A or B. Now constructing the truth table. How many inputs? Two inputs, A and B. How many outputs? One output, that is Y. Now, I consider both the inputs as 0. A is 0, B is 0. Both the inputs are low. Both the inputs are off. Then you see 0 plus 0, mathematical operation, the output is 0. So if both the inputs are low, 0 and 0, the output is also low. Now A is 0, B is 1. 0 plus 1, the output is 1, which is high. A is 1, B is 0. 1 plus 0, which is 1. A is 1, B is 1. Now the remainder, binomial remainder, is 1. So if you can keenly observe the table, the output of the OR gate is high. You get a high state output for the OR gate when any one of the inputs is high. One of the inputs has to be high if you have to get a high output. As you can see here, if both the inputs are low, if both the inputs are in the off state, then the output of the OR gate is also off. So this is the symbol. Logical expression Y equals A or B. Mathematical operation is addition. The output of OR gate is high when one of the inputs is high. If both the inputs are low, then the output is low. That is what I have described here. Next, AND gate. Again, this is the symbol of the AND gate. This is the AND gate. Again, if you see, there are two inputs, A and B, and the output is A dot B. Now, you don't read this as A dot B, you read this as A and B. So, the mathematical operation it is performing is multiplication. So, 0 into 0, 0. 0 into 1, 0. 1 into 0, 0. 1 into 1 is 1, which means the output of the AND gate is high when both the inputs are high. If any one of the input is low, if any one of the input is in the 0 state, then the output of the AND gate is also low. So we get a high output, an output in the ON state when both the inputs are high. And finally, a very beautiful gate called as NOT gate. It is also called as the inverter gate or the complementer gate, and it is represented by a bubble at the tip. So clearly you observe here a NOT gate, which is called the inverter gate, has only one input as well as one output. So y equals A complement. A bar is the expression. So whatever input is fed to the NOT gate, the output will be reverse of that. The output will be inversion of that. So if you observe, if A is 0, A bar is 1. It is inverting the input. If the input is low, the output is high. If A is 1, A bar is 0. If the input is high, the output is low. Therefore, you call this as inverter or complementer. It will invert the given input. So, this is called as the NOT gate. So, students, in my session today, we have understood the function of the fundamental gates, meaning of digital electronics, what actually is a logical gate, and so on. In my next session, we will wrap up the chapter by studying higher gates. Until then, have a nice time. Thank you.